Question number 1, part A. Simplify the expression. So we have been given the expression there without using mathematical tables, and then expressing the answer correctly to two significant figures. Okay, so first let us express the numbers without decimals. So our expression is going to be 25 times 885 times 25 times 10 power negative 4 over 625 times 5 times 10 power negative 6. Okay, so now let us multiply this 25 and this 25. Our expression is going to be 625 times 885 times 10 power negative 4 over 625 times 5 times 10 power negative 6. Okay, so this 625 will cancel for both numerator and denominator. Then our expression is going to be 885 times 10 power negative 4 over 5 times 10 power minus 6. Okay, so now let us divide this 885 by 5, and then we are going to combine the exponential numbers. Our expression is going to be 177 times 10 squared, of which after solving the values we are going to have 17,700. Okay, so expressing this into two significant figures, our answer is going to be 18,000. Part B, Roman 1. Mr. Magani set an examination weighing a total of 96 marks with the following distributions. 20% of the marks were awarded for reading, 40% for writing, 15% for the practical, and the remaining percentage for spelling. Find the marks that were awarded for spelling. Okay, so this is the percentage problem. To find the marks for spelling, we are just going to take the total marks minus sum of all the marks for reading, writing, and practical. Okay, so let us find the marks for reading, writing, and practical. So the marks for reading is going to be 20% of 96, which equals to 20 over 100 times 96, of which solving the values we are going to get 19.2. And also the marks for writing is going to be 40% of 96, which equals to 40 over 100 times 96, of which after solving the values we are going to get 38.4. And also the marks for practical is going to be 15% of 96, which equals to 15 over 100 times 96, of which solving this we are going to get 14.4. Okay, so therefore spelling marks are going to be 96 minus 19.2 minus 38.4 minus 14.4, of which after solving these values we are going to get marks for spelling, which equals to 24 marks. Roman 2. 3 airplanes arrived at Kilimanjaro International Airport at the intervals of 30 minutes, 40 minutes, and 55 minutes. If all 3 airplanes arrived at Kia at 2 o'clock p.m. on Saturday, when and at what time would they arrive together again? Okay, so this is the LCM word problem. So we need first to find the number that is common multiple for 30 minutes, 40 minutes, and 55 minutes. This will be minutes from 2 p.m. o'clock, where the airplanes will meet again. Okay, so now let us find the LCM for the minutes given. Okay, so we are going to prepare a small table with the given numbers. So here we are having 30, and here is 40, and here is 55. And then we are going to ask ourselves what is the lowest number which can divide either of these three numbers. So our first number is 2. So we are going to have 30 over 2, here is 15, and here is 40 over 2, which equals to 20. And here is 55 is not divisible by 2, so we are leaving 55 as it is. Our next number is 2, so dividing here we are going to have 15, and here is 10, and here is 55. The next number is 2, so here is 15, and here is 5, and here is 55. Our next number is 3, so here is 5, and here is 5, and here is 55. Our next number is 5, so the value here is 1, and here is 1, and here is 11. And our next number is 11, so dividing here is 1, and here is 1, and here is 1. Okay, so now to find their LCM, we are going to find the product of all the factors. So LCM is going to equal 2 times 2 times 2 times 3 times 5 times 11, of which after solving the values, we are going to have LCM equals to 1320. Okay, so these are the minutes which are going to be taken for airplanes to arrive again at the same time. Okay, so let us add these minutes to 2 o'clock p.m. in order to know when these planes are going to arrive again. Okay, so let us convert these minutes in terms of hours. So we are going to take 1320 minutes divided by 60, of which solving this we are going to have 22 hours. Okay, so next we are going to take this 2 o'clock p.m. Sunday plus 22 hours, which is going to be 12 o'clock noon on Monday. Okay, so therefore the airplanes will arrive at 12 o'clock noon on Monday. Question number 2, part A. If that expression equals to A plus B under root C, find the values of A, B, and C. Okay, so this is the radical problem, and to find the values of letters, we need to write the left-hand side in a format of a right-hand side so that we can compare the position of the number and letters from both sides. Okay, so let us now consider our left-hand side. Okay, so for this one, first we are going to rationalize the denominator by multiplying 2 minus under root 3 for both numerator and denominator. Something to note is this 2 minus under root 3 is a denominator that has been changed the sign from addition to negative sign. Okay, so rationalizing this, we are going to have under root 3 times in brackets 2 minus under root 3 over in brackets 2 plus under root 3 times 2 minus under root 3. Okay, so now let us open the brackets of a numerator. And for the denominator, we are going to expand the expression by applying the difference of two square technique. Then our expression is going to be 2 under root 3 minus under root 3 times under root 3 over 2 squared minus under root 3 squared. Okay, also this can be written as 2 times under root 3 minus under root 3 squared over 2 squared minus under root 3 squared. Okay, so we have to remember that any number, when it is under root and it is squared, equals to the same number, which means this under root 3 squared is going to equal 3. Okay, so using that concept, our expression is going to be 2 under root 3 minus 3 over 4 minus 3. Okay, so simplifying this further, our expression is going to be 2 under root 3 minus 3. Rewriting this, we are going to have negative 3 plus 2 under root 3. Okay, so now we have negative 3 plus 2 under root 3 equals to a plus b under root c. Okay, so since we have the same format from both sides, then we are going to compare the numbers with the letters which having the same position. So from this one, we are going to say negative 3 equals to a, 2 equals to b, and 3 equals to c. And these are our answers. Part B of the question, Roman 1, solve the equation 9 over under root 3 power 2x equals to 1 over 81. Okay, so this is the exponential problem, and to solve the problem, we need to express both sides in the same base so that we can compare the exponents. Okay, so let us now rewrite this equation. We are going to have in brackets 3 squared over 3 power half power 2x equals to 3 power 0 over 3 power 4. Okay, so something to remember is any number power 0 equals to 1. And also, we have to recall the division rule for the powers of the same base, which says a power x over a power y equals to a power x minus y. Okay, so now let us apply this concept in our expression. Then our equation is going to be in brackets 3 power 2 minus half power 2x equals to 3 power 0 minus 4. Solving this, we are going to have in brackets 3 power 3 over 2 power 2x equals to 3 power negative 4. Okay, so now let us multiply the exponents on the left hand side. We are going to have 3 power 3x equals to 3 power negative 4. Okay, so let us now compare the exponents. Since our bases are the same, we are going to have 3x equals to negative 4. Next, let us make x as a subject. We are going to have x equals to negative 4 over 3. And this is the value required. For Roman 2, given that log 2 equals to 0.3010 and log 3 equals to 0.4771, we are supposed to find log 2 1/4 without using mathematical table. Okay, so this one is a logarithm problem, and to solve this, first let us express this log 2 1/4 in the form that will help us to substitute the values of logarithms given. So first, we are going to express this mixed fraction as an improper fraction. Then we are going to have log 9/4. Then we are going to apply the quotient rule of logarithm. Then we are going to have log 9 minus log 4. Then next, let us express these two numbers 9 and 4 in exponential form. Our expression is going to be log 3 squared minus log 2 squared. Okay, so now let us apply the exponential rule of logarithm. We are going to have 2 log 3 minus 2 log 2. Now we can substitute the values of logarithm given. We are going to have 2 times 0.4771 minus 2 times 0.3010. Computing this, we are going to have 0.3522. And this is the value of logarithm required. Question number 3. In a certain school, 40 students were asked about whether they like tennis or football or both. It was found that the number of students who like both tennis and football was 3 times the number of students who like tennis only. Furthermore, the number of students who like football only was 6, more than twice the number of students who like tennis only. However, 4 students like neither tennis nor football. Part A of the question, represent this information in a Venn diagram, letting X be the number of students who like tennis only. Okay, so this is the set problem. We have been told that we are going to let X as a student who like tennis only. Okay, so from the information given, the students who like both tennis and football is going to be 3x. And the students who likes football only are going to be 2x plus 6. And the 4 students like neither tennis nor football. Okay, so we are going to sketch our Venn diagram. We are going to draw a table, and then we are going to have 2 cycles, one for tennis and the other one for football. Okay, so now let us label our Venn diagram. So here we are going to have x, and here is 3x, and here is 2x plus 6, and here is 4. And this is our Venn diagram requested. Part B, use the results obtained in Part A to determine the probability that a student selected at random likes Roman 1, football only. Okay, so to find the probability that a student selected like football only, we first find the variable x. We know that students who like tennis only plus students who like football only plus students who like both plus students who like neither equals to 40. So now let us apply the values which we have. So we are going to have x plus, in brackets, 2x plus 6 plus 3x plus 4 equals to 40. For this one, simplifying this equation and solving for x, we are going to have x equals to 5. Okay, so from probability formula, probability of an event is given by probability equals to number of events over number of sample space. Note that number of events equals to students who like football only, which equals to 2x plus 6. And also number of sample space equals to the total number of students, which equals to 40. Then our probability of events is going to be 2x plus 6 over 40. Now let us substitute the value of x with the 5. We are going to have probability of events equals to 16 over 40. Simplifying this, we are going to have probability of events equals to 2 over 5. And this is the probability needed. For Roman 2, we are supposed to find the probability for both football and tennis. Okay, so from the probability formula, probability of events equals to number of events over number of sample space. Okay, so number of events equals to students who like both football and tennis, which equals to 3x. And also number of sample space equals to total number of students, which equals to 40. Then our probability of event is going to be 3x over 40. Substituting the value of x, which equals to 5, we are going to have probability of event equals to 15 over 40. Simplifying this, we are going to have probability of an event equals to 3 over 8. And this is the probability required. Question number 4, part A, Roman 1. A line whose gradient is 3 over 4 has the x-intercept of -3. Find the equation of the line in a form of y equals to mx plus c, where m and c are constants. Okay, so this is the coordinate geometry problem. We've been given that x-intercept equals to -3. We have to remember that x-intercept is when y equals to 0, meaning our point is -3, 0. We have the gradient, which equals to 3 over 2, using the formula for gradient, which says change in y over change in x. Symbolically, we can write this as m equals to y minus y1 over x minus x1. Okay, so we have the values for x1 and y1, which equals to -3, 0, and we have the value for m, which equals to 3 over 2. Okay, so now let us substitute these values into our formula. Our equation is going to be 3 over 2 equals to y minus 0 over x minus -3. Let us now compute our right hand side. Our equation is going to be 3 over 2 equals to y over x plus 3. Okay, so let us now make y as a subject. Our equation is going to be y equals to 3 over 2x plus 9 over 2. And this is an equation required. For Roman 2, find the length of a line segment joining the points 3, -2 and 15, 3. Okay, so to find the length of a line joining segment, we are going to use a distance formula which says distance equals to under root in brackets x2 minus x1 squared plus y2 minus y1 squared. Okay, so we have the values for x1 and y1 which equals to 3, negative 2, and we have the values for x2 and y2 which equals to 15, 3. Okay, so let us now substitute these values into our equation. We are going to have distance equals to under root in brackets 15 minus 3 squared plus in brackets 3 minus 2 squared. Okay, so solving this, we are going to have distance equals to under root 169. Solving this, we are going to have distance equals to 13 units, and this is the length required. Part B, a boat sails due north at a speed of 120 kilometers per hour and the wind blows at a speed of 40 kilometers per hour due east. Find the actual speed of the boat. Use under root 10 equals to 3.16. Okay, so this is the vector problem. The actual speed of the boat will be the resultant of the speed of the boat and the speed of the wind. Okay, so let us sketch the problem. We start with the boat direction due north, which equals to 120 kilometers per hour, and then we are drawing another line for the wind direction, which equals to 40 kilometers per hour, and then we are going to draw another line for the actual speed, which is going to be our resultant. Okay, so now to get the value of our resultant from the sketch, we are going to use a Pythagoras theorem. So we are going to let boat speed equals to B, and then we are going to let wind speed equals to W, and then we are going to let resultant equals to R. Then the Pythagoras theorem states that R squared equals to B squared plus W squared. Okay, so now let us substitute the values which we have. Our equation is going to be R squared equals to 120 squared plus 40 squared. Okay, so now applying the root both sides and making computation, we are going to have R equals to under root 16,000. We can write R as R equals to under root 1,600 times under root 10. Okay, so from the question, we have been given under root 10 equals to 3.16, and also we know that under root 1,600 equals to 40. Then let us apply these values in order to find the value of R. Then R equals to 40 times 3.16. Solving this, we are going to have R equals to 126.4. So we are going to say that the actual speed of the boat equals to 126.4 kilometers per hour. Question number 5, part A. In the following triangle, ABC, AB equals to 8 centimeter, BC equals to 11.3 centimeter, and angle ABC equals to 30 degrees. Find the area of the triangle. Okay, so this is the geometric problem. And since we have two values for sides and an angle between them, we can use the following formula for an area, which says area equals to 1 over 2 times AB times BC times sine theta. Okay, so let us substitute the values into our formula. Our equation is going to be area equals to 1 over 2 times 8 times 11.3 times sine 30 degrees. Okay, so we have to know that the value for sine 30 degrees equals to 0.5. Okay, so solving the values, our area is going to be 22.6 centimeter squared. And this is an area of a triangle required. Part B, Roman 1, find the perimeter of a regular hexagon inscribed in a cycle whose radius is 100 meters. Okay, so this is the geometric problem. We can use the following formula to find the perimeter for a polygon inscribed in a cycle, which says perimeter equals to 2nr sine in brackets 180 degrees over n. Okay, so for the hexagon, n equals to 6, and we've been given radius equals to 100 meters. Okay, so let us substitute these values into our formula. Our equation is going to be perimeter equals to 2 times 6 times 100 times sine 180 over 6. Okay, so solving the values inside the sign, we are going to have perimeter equals to 2 times 6 times 100 times sine 30. Okay, so solving this, we are going to have perimeter equals to 600 meters. And this is going to be our answer. Roman 2, given that AB over KL equals to BT over LC, which equals to TA over CK, which equals to 3, where AB, BT, and TA are the sides of a triangle, ABT and KL, LC and CK are the sides of a triangle KLC. What does this information implies? Okay, so this is the similarities problem, and given this information, this implies that triangle ABT and KLC are similar since their corresponding sides are proportional, meaning the ratio is constant, and the corresponding angles will also be equal. Okay, so moving on to question number 6, part A. The variables t and z in the following table are related by the formula z equals to at power n, where a is a constant and n is a positive integer. So for Roman 1, we are supposed to use the data from the table given to determine the values of a and n. Okay, so the given equation is z equals to at power n. Okay, so let us take t, which equals to 1, and z, which equals to 0.5 from our table above. We are going to substitute this into our formula. Then we are going to have 0.5 equals to a times 1 power n. Okay, so we know that 1 exponent, any number, gives 1. Therefore, our equation is going to be 0.5 equals to a. Okay, so using the same formula given, now we are going to take other values from the table. We are going to take t equals to 2 and z equals to 4, and then we are going to substitute these values into our formula. We are going to have 4 equals to a times 2 power n. But we have the value for a, which equals to 0.5. Let us now substitute this value. Our equation is going to be 4 equals to 0.5 times 2 power n. Let us now divide 0.5 both sides. We are going to have 8 equals to 2 power n. Okay, so next, let us express our left-hand side as base 2. Our equation is going to be 2 power 3 equals to 2 power n. Okay, so now let us compare the exponents because their bases are the same. Our expression is going to be 3 equals to n. So we can conclude that a equals to 0.5 and n equals to 3. For Roman 2, we are supposed to use the values of a and n obtained in part A above in order to complete the following table. Okay, so let us consider the same formula which says z equals to at power n. Now we are going to substitute the value of a, which equals to 0.5, and n equals to 3. Then our equation is going to be z equals to 0.5 t power 3. To complete the table, let us substitute t equals to 4 and t equals to 5. We are going to start with t equals to 4. Then our equation is going to be z equals to 0.5 times 4 power 3, which after solving this, we are going to have z equals to 32. Next, when t equals to 5, then our equation is going to be z equals to 0.5 times 5 power 3, of which solving this, we are going to get 62.5. Now we can complete our table by having these values. So the value here is going to be 32, and here the value is going to be 62.5. For part B, if v varies directly as the square of x and inversely as under root of y, given that v equals to 18 when x equals to 3 and y equals to 16, find the value of v when x equals to 5 and y equals to 4. Okay, so this is the variation problem. Let us write the expression symbolically. We are going to have v varies directly as the square of x and inverse as under root of y. Okay, so now let us remove the proportionality symbol by applying the constant of proportionality k. Our expression is going to be v equals to k x squared times 1 over under root y. Okay, so now let us make k as a subject. Our equation is going to be k equals to v times under root y over x squared. Okay, so now to find the value of k, we are going to substitute the value of v, which equals to 18, x, which equals to 3, and y equals to 16. Then our expression is going to be K equals to 18 times under root 16 over 3 squared, of which, solving this, we are going to get K equals to 8. Okay, so using the same formula, let us now substitute the values for x equals to 5 and y equals to 4 and k equals to 8 in order to find the value of v. Then our expression is going to be 8 equals to v times under root 4 over 5 squared. Okay, so next we are going to make v as a subject and we are going to make computation. We are going to have v equals to 100 and this is the value required. Question number 7, Part A, Roman 1. A school has 2,000 students, of whom 1,500 are boys. What is the ratio of boys to girls in the school? Okay, so this is the ratio problem. To find the ratio required, let us first find the number of girls available. Okay, so number of girls will equal number of students minus number of boys. Okay, so we are going to take 2,000 minus 1,500. Then we are going to get 500, and this is the number of girls. Okay, so the ratio of boys to girls is going to be 1,500 ratio 500, of which, simplifying this, we are going to have 15 ratio 5. Let us simplify this further. We are going to have 3 ratio 1. Therefore, the ratio of boys to girls equals to 3 ratio 1. Roman 2. Matiku bought a book for Tanzania shillings 120,000. A year later, he sold the book at a profit of 20%. What was the selling price of the book? Okay, so this is the percentage problem. We know that profit equals to selling price minus buying price. And we know that percentage of profit equals to selling price minus buying price over buying price times 100. Okay, so now let us apply the numbers which we've been given. We are going to have 20 equals to selling price minus 120,000 over 120,000 times 100. Okay, so next let us divide by 100 both sides. Our equation is going to be 0.2 equals to selling price minus 120,000 over 120,000. Okay, so let us now cross multiply this equation. Our equation is going to be 0.2 times 120,000 equals to selling price minus 120,000. Okay, so now let us make selling price as a subject. Our equation is going to be selling price equals to 120,000 plus 0.2 times 120,000. After solving the values, we are going to get a selling price equals to 144,000. And this is going to be our answer. Part B of the question, Halima started a business on 1st September 2018 with a capital of Tanzania shillings 25,000 in cash. So we have been given several transactions there. Using these transactions, we are supposed to prepare the cash account. Okay, so we just have to recall that a cash account is the account which records cash transactions. And it has two sides, the debit side and a credit side. So we are going to sketch the cash account, which will have a debit side and a credit side. And also on the debit side, we are going to have 4 columns, and on our credit side we are going also to have 4 columns. We are going to have a column for date, particular, folio, amount for the both sides of the cash book. Okay, so let us now start listing the transactions which we have been given from the question. The first one is the cash capital of 25,000. Next is the cash purchases of 15,000. Next is the cash sales of 3,000. The next one is the cash sales of 5,000. The next one is payment of carriage on goods of 500. The next one is the cash sales of 14,000. The next transaction is the cash purchases of 1,000. The next one is the payment of rent 2,000. The next one is purchases of good 6,000. The next one is the payment of wages 5,000. The next transaction is the sales of good on credit 1,000, but this one we are not going to include in a cash book because it's not a cash transaction. Okay, so we have finished all the transactions. Let us now finalize our cash book by finding the sum on our debit side, which after summing the values here, the total is 48,000. And also we are going to take the same value on our credit side here, 48,000. Now we are going to find the balancing figure here, which after finding the values, the figure is 18,500. And also this is going to be our balance brought down on a following period, the same value, 18,500. And this is our cash book. Question number 8, part A. Find the first term and the common difference of an arithmetic progression whose fifth term is 21 and the eighth term is 30. Okay, so this is an arithmetic progression problem of which it is mainly characterized by the fact that there is a common difference between any two consecutive terms. Okay, so to find the term required, we are going to refer to the general formula for finding any term in a progression, which says an equals to a1 plus, in brackets, n minus 1 times d, of which an is any term at a position n, a1 is a first term, and d is a common difference, and n is a position of a term. Okay, so from the question, the fifth term is 21, meaning n equals to 5 and an is 21. Okay, so let us now substitute these values into our equation. We are going to have 21 equals to a1 plus, in brackets, 5 minus 1 d. Simplifying this equation and rearranging it, we are going to have A1 plus 4D equals to 21. We are going to call this as equation number 1. Okay, so we also have 8th term equals to 30, then n equals to 8, and an equals to 30. Let us now substitute these values into our equation. We are going to have 30 equals to a1 plus, in brackets, 8 minus 1 times d. Okay, so simplifying this equation and rearranging it, we are going to get a1 plus 7d equals to 30. And then we are going to call this as equation number 2. So now we have two simultaneous equations. Okay, so let us take equation number 1 minus equation number 2. Then we are going to have a1 plus 7d equals to 30 minus a1 plus 4d equals to 21. Okay, so the value here is going to be 0, and here is plus 3d, and here is 9. Okay, so 3d equals to 9. Let us now divide by 3 both sides. Our equation is going to be d equals to 3. Okay, so now let us substitute d equals to 3 in equation number 1 in order to solve for a1. Our equation is going to be a1 plus 4 times 3 equals to 21. Solving for a1, we are going to have a1 equals to 9. Therefore, our first term is 9 and the common difference is 3. Part B, find the 10th term of a sequence whose first 3 consecutive terms are 5, 15, and 45. Leave the answer in exponent form. Okay, so from the terms given, we can see that the common ratio is 3. This means that this is the geometric progression. Okay, so we have been given the first term of the geometric progression is 5, the second term is 15, and the third term is 45. Okay, so to find the 10th term, we are going to consider the following formula for finding any term in the geometric progression, which says Gn equals to G1 R power n minus 1, of which Gn is any term at any position n, G1 is a first term, and R is a common ratio. Okay, so for the 10th term, n is going to be 10, and also we have G1 which equals to 5, and we have R equals to 3. Let us now substitute these values into our formula. We are going to have G10 equals to 5 times 3 power 9. In exponential form, we can write this as 5 in brackets 3 power 9. And this is going to be our answer. Question number 9, part A. In the following figure, AP is perpendicular to BC, AB equals to 13 cm, BP equals to 5 cm, and AC equals to 15 cm. Calculate the length of AP and CP. Okay, so this is the geometry problem. Since line AP is perpendicular to BC, then we can use the Pythagoras theorem to find the required sides. Okay, so let us consider the triangle ABP. Applying the theorem, we are going to have AB squared equals to AP squared plus BP squared. Okay, so now let us apply the given numbers our equation is going to be 13 squared equals to AP squared plus 5 squared. Okay, so now let us make AP squared as a subject. Our equation is going to be AP squared equals to 13 squared minus 5 squared. Okay, so next we are going to apply the square root both sides. Our equation is going to be AP equals to under root 13 squared minus 5 squared. Simplifying this, we are going to have AP equals to under root 144. Finding the root, we are going to have AP equals to 12 centimeters. Okay, so for the length CP, let us consider the triangle APC, and then applying the theorem, we are going to have AC squared equals to AP squared plus CP squared. Okay, so let us now substitute the values given. We are going to have 15 squared equals to 12 squared plus CP squared. Next, let us make CP squared as a subject. Our equation is going to be CP squared equals to 15 squared minus 12 squared. Applying the square root, we are going to have CP equals to under root 15 squared minus 12 squared. Solving this, we are going to have CP equals to under root 81. Finding the root, we are going to have CP equals to 9 centimeters. And also this is the length required. Part B of the question, from the top of the building 75 meters high, John sees a lorry and a minibus along the road, both being on one side of the building at the angles of depression 30 degrees and 60 degrees respectively. Roman 1, we are supposed to sketch a diagram representing this information. Okay, so here we have John's position. So we are going to draw a line representing the building, and then we are going to draw another line representing the ground, and then we are going to have 2 points here for the minibus and here for the lorry. And then let us connect these 2 lines with the John's position from the minibus and also from the lorry. And then let us label our triangle. So here is A, here is C, here is D, here is E, and here is 75 meters, here is 60 degrees, and here is 30 degrees. And this is our sketch. For Roman 2, we are supposed to determine the distance between the cars, leaving the answer in a third form. Okay, so to find the distance between the 2 cars, let us first find line CD. Okay, so from the triangle ACD, let us apply the tangent formula, which says tan theta degrees equals to opposite side AC over adjacent side CD. Let us now apply the values which have been given from the sketch. We are going to have tan 60 degrees equals to 75 over CD. Okay, so let us now make CD as a subject. We are going to have CD equals to 75 over tan 60 degrees. Okay, so from the table, tan 60 degrees equals to 1.732. Let us apply this value into our equation. We are going to have CD equals to 75 over 1.732. Solving this, we are going to have CD equals to 43.3 meters. Next, let us find the value for line CE. Then we are going to apply the tangent formula for a triangle ACE, of which our opposite side is going to be AC and adjacent side is CE. Okay, so let us apply the values. We are going to have tan 30 degrees equals to 75 over CE. Now let us make CE as a subject. We are going to have CE equals to 75 over tan 30 degrees. From the table, tan 30 degrees equals to 0.5774. So let us apply this value into our formula. We are going to have CE equals to 75 over 0.5774. Solving this, we are going to have CE equals to 129.9 meters. Now to find the distance between the cars, we are going to take CE minus CD. Okay, so distance is going to be 129.9 minus 43.3, which after solving this, we are going to have 86.6 meters. And this is the distance required. Question number 10, part A. Rachel is 3 years older than her brother John. 3 years to come, the product of their ages will be 130 years. Formulate a quadratic equation representing this information. Hence, by using the quadratic formula, find their present ages. Okay, so this is the algebraic problem. Let us represent their age by letting x equals to John's age. Rachel is 3 years older. Then we are going to have x plus 3. Their age 3 years to come will be John equals to x plus 3. Rachel's age will equal, in brackets, x plus 3 plus 3, which solving this we are going to get x plus 6. And also we've been told that 3 years to come, the product of their age is going to be 130. Then the equation will be, in brackets, x plus 3 times, in brackets, x plus 6 equals to 130. Okay, so now let us expand our left-hand side. We are going to have x squared plus 9x plus 18 equals to 130. Okay, so let us express this equation in a standard quadratic format. Our equation is going to be x squared plus 9x minus 112 equals to 0. And this is the required equation. Okay, so next, let us solve for x by using the quadratic formula, which says x equals to minus b plus or minus under root b squared minus 4ac over 2a. From our equation, a equals to 1, b is 9, and c is negative 112. Then let us apply these numbers into our formula. Our equation is going to be x equals to negative 9 plus or minus under root 9 squared minus 4 times 1 times negative 112 over 2 times 1. Solving this, we are going to have x equals to negative 9 plus or minus 23 over 2. Then x is going to equal negative 9 plus 23 over 2, or x equals to negative 9 minus 23 over 2. Solving further, we are going to have x equals to 7, or x equals to negative 16. So for here, we are going to take the positive value since the age cannot be negative value. Then the age of John is 7 years old, and the age of Rachel is going to be 7 plus 3, which equals to 10 years old. Okay, so for part B, the sum of the squares of two consecutive positive numbers is 61. Find the numbers. Okay, so for this one, we have to remember that consecutive numbers are the numbers that differ by 1. Okay, so first let us assume the first number is x. Then our second number will be x plus 1. Okay, so for the squares of the numbers, the first number we are going to have x squared. And also for the second number we are going to have in brackets x plus 1 squared. Okay, so finding the sum of the squares, let us sum these two numbers. Our equation is going to be x squared plus in brackets x plus 1 squared. We have been told that the result of this summation is going to be 61. So we are going to equal 61. Okay, so next we are going to expand this expression x plus 1 squared. Then our equation is going to be x squared plus x squared plus 2x plus 1 equals to 61. Okay, so next we are going to combine the like terms, and we are going to express the equation in a standard quadratic format. Then our equation is going to be 2x squared plus 2x minus 60 equals to 0. Okay, so now let us recall the formula for solving the quadratic equation, which says x equals to negative b plus or minus under root b squared minus 4ac over 2a. Okay, so from our equation, a is 2, and b is 2, and c equals to negative 60. So let us use these values into our formula. Then our equation is going to be x equals to negative 2 plus or minus under root 2 squared minus 4 times 2 times negative 60 over 2 times 2. Solving this, we are going to have x equals to negative 2 plus or minus 22 over 4. Then we can say that x equals to negative 2 plus 22 over 4, or x equals to negative 2 minus 22 over 4, which is going to give us x equals to 5, or x equals to negative 6. Okay, so now let us consider when x equals to 5, then our first number is 5 and our second number is going to be 5 plus 1, which equals to 6. And also, considering when x equals to negative 6, then our first number is negative 6 and our second number is going to be negative 6 plus 1, which equals to negative 5. Therefore, the numbers are 5 and 6, or negative 6 and negative 5. Okay, so question number 11. The following data represent the marks scored by 36 students on a certain school in geography examination. So we've been given several information there. Part A, we are supposed to prepare a frequency distribution table representing the given data by using the class intervals 50 to 54, 55 to 59, and so on. Okay, so this is the statistical problem. We have to recall that a frequency distribution table is a table that contains class intervals and their corresponding frequencies. Okay, so from the intervals given, the class size for the data is 5. Okay, so let us sketch our table, which is going to have a class interval and their corresponding frequencies. So we've been given several intervals there, and we are going to follow the same trend in order to fill all the class intervals. So the first one is 50 to 54, 55 to 59, 60 to 64, 65 to 69, 70 to 74, 75 to 79, 80 to 84, 85 to 89, and 90 to 94. Next, we are going to complete our frequency distribution table by counting the number of data that are within the particular class interval. Okay, so counting the information, for example, in this class interval 50 to 54, counting the values, we find they are 3. For the next class, the values are 2. The next one, they are 7. The next one, they are 4. Next, it is 11. The next one is 2. The next one is 4. Next is 2. And the last one is 1. So to finalize our table, we are going to find the summation of frequencies. For here, after summing the values, we are going to get 36. And this is the frequency distribution table required. Part B, use the frequency distribution table obtained in Part A above, Roman 1, in order to draw a histogram. Okay, so the histogram is a graph that contains rectangle bars drawn by frequency against their class mark. Okay, so let us now modify our table by adding a class mark column. We have to remember that a class mark represented by letter X is obtained by taking the upper limit plus the lower limit over 2. For example, for the first class interval, we are going to take 50 plus 54 divided by 2, for which is going to be 52. So we are going to use the same trend to fill the remaining classes with their class mark. Okay, so for the next one is going to be 57, the next is 62, next is 67, next is 72, next is 77, next is 82, next is 87, and the last one is 92. Okay, so for the histogram, we are going to start by drawing axes and we are going to label them, of which for frequency we are going to label on y-axis and the class mark on the x-axis, and then we are going to draw the bars according to the data and shade them. And our final drawing will be like this. For Roman 2, we are supposed to calculate the median and we are supposed to write the answer correct to 2 decimal places. Okay, so to find the median, we are going to add another column in our table for the cumulative frequency. Okay, so our cumulative frequency data, for the first one we are going to take 3. For the second one, we are going to take this 3 plus 2, which equals to 5. For the third one, we are going to take 5 plus 7, which equals to 12. And then using the same approach, we are going to fill the remaining parts. The next one is going to be 16. Next is going to be 27. Next is 29. Next is 33. Next is 35. And the last one is 36. Okay, so to find the median, let us consider the formula which says median equals to L plus, in brackets, summation of F over 2 minus B over M times C, of which L is a lower real limit for the median class, B is a sum of the frequencies before the median class, M is a frequency of a median class, C is a class size, and the summation of F is a sum of frequencies. Okay, so to identify the median class, we are going to look for where the value of summation of F over 2 falls from the cumulative frequencies. Okay, so summation of F over 2 equals to 36 over 2, which solving this equals to 18. And we can see that 18 falls within 27 cumulative frequency, of which the class for this row is 70 to 74, and this is the median class. Okay, so from the median class, the lower limit minus 0.5 equals to 70 minus 0.5, which equals to 69.5, and this is going to be the value of L. And for the sum of the frequency before 27 equals to 16, the median frequency from the column frequency equals to 11, and the class size equals to 5. Okay, so now let us substitute these values into our formula. We are going to have median equals to 69.5 plus, in brackets, 18 minus 16 over 11 times 5. Solving this, we are going to have median equals to 70.41, and this is the value required. Question number 12, part A. Two towns, A and B, are located at those coordinates respectively. Roman 1. Find the distance between the two towns in kilometer. Use radius of the earth that match. Give the answer to nearest whole number. Okay, so this is the earth as a sphere problem. Since the points are located in the same latitude but different longitude, to find the distance between them, we are going to use the following formula, which says L equals to 2 pi r theta cos phi over 360 degrees, of which theta is a difference in longitude. Then we are going to take 43 minus 38, which equals to 5. And phi is the common latitude of the towns, which is 10. Then reading cos 10 from the table equals to 0.9848. Then substituting these values, our equation is going to be L equals to 2 times 3.14 times 6,400 times 5 times 0.9848 over 360 degrees. Solving this, we are going to have L equals to 549.74, which we can approximate this as 550. Therefore, the distance is 550 kilometers. For Roman 2, suppose a ship sailing at 50 kilometers per hour from town A to town B. Using the answer obtained in part A above, find how long will the ship take to reach town B. Okay, so to find how long, then let us consider the following formula, which says speed equals to distance over time. Okay, so given speed equals to 50 kilometers per hour, calculated distance is 550 kilometers. Let us substitute these values into our formula. Then we are going to have 50 equals to 550 over time. Okay, so now let us make time as a subject. Our equation is going to be time equals to 550 over 50. Simplifying this, we are going to have 11. Therefore, the ship is going to take 11 hours to reach town B. Part B, the following figure represents a rectangular prism in which PQ equals to 12 cm, QR equals to 8 cm, and RY equals to 4 cm. For Roman 1, we are supposed to find the total surface area. Okay, so this is the 3-dimension problem. Let us consider the formula to find an area of a rectangular prism, which says area equals to 2 times, in brackets, L times W plus 2, in brackets, L times H plus 2, in brackets, H times W, of which L is a length which we've been given as 12 centimeters, W is a width which we've been given as 8 centimeters, and H is a height which equals to 4 centimeters. Okay, so now let us substitute these values into our formula. We are going to have area equals to 2, in brackets, 12 times 8 plus 2 in brackets 12 times 4 plus 2 in brackets 4 times 8. Solving this, we are going to have area equals to 352. Therefore, the area is going to be 352 centimeters squared. For Roman 2, we are supposed to find the angle between the planes PTZW and QRZW. Okay, so the angle between those two planes is an angle PWQ. Okay, so let us sketch the problem. We are going to draw our triangle PWQ, of which here is 4 centimeters, here is 12 centimeters, and here is our required angle. Okay, so let us now apply the tangent formula for a triangle PQW. The formula says tan theta equals to opposite side, in our case is PQ, over adjacent side, in our case is PW. Okay, so let us apply the numbers. We are going to have tan theta equals to 12 over 4. Solving this, we are going to get tan theta equals to 3. Okay, looking for the inverse of tangent 3 from the table, we are going to have theta equals to 71.57, and this is an angle between the planes. Part C of the question, calculate the volume of a cone whose base radius is 12 cm and the slant height is 20 cm. Use pi equals to 3.14. Okay, so let us recall the formula for the volume of a cone, which says volume equals to 1 over 3 pi r squared h, of which we have not been given the value for the height, but instead we have been given the value of a slant height. So we are going to use a Pythagoras theorem in order to find the value for h. Okay, so let us consider the sketch for a cone. So the value here is r for our radius, and here is h for the height, and here is I for the slant height. Then to find the value for h, we are going to use a Pythagoras theorem, which for this case is going to be L squared equals to h squared plus r squared. So now let us substitute the values which we have. We are going to have 20 squared equals to h squared plus 12 squared. Now making h as a subject, our equation is going to be h equals to under root 20 squared minus 12 squared. Solving this, we are going to have h equals to under root 256. Finding the root for this one, we are going to have h equals to 16. Okay, so now let us apply the values we have to find the volume of a cone. Then our equation is going to be v equals to 1 over 3 times 3.14 times 12 squared times 16, of which after solving the values we are going to have volume equals to 2411.52 centimeter cubic, and this is the volume of a cone. Question number 13, part A. The inverse of a matrix A is that matrix. Then we are supposed to find the matrix. Okay, so this is the matrix problem. We have been given the inverse of a matrix. Okay, so we have to recall that a matrix times its inverse gives us an identity matrix, which means matrix A times matrix A inverse equals to identity matrix. And we have to remember that identity matrix for 2 by 2 matrix is 1, 0, 0, and 1. Okay, so now we are going to let A equals to matrix A, B, C, and D. And we have A inverse, which equals to matrix 4, 5, 3, and 2. So let us multiply these two matrices. Then we are going to equate our equation to identity matrix. Then our equation is going to be matrix 4, 5, 3, 2 times matrix A, B, C, D equals to matrix 1, 0, 0, 1. Okay, so next we are going to multiply our matrices in our left hand side. Then our equation is going to be 4A plus 3B 5A plus 2B 4C plus 3D 5C plus 2D equals to matrix 1, 0, 0, 1. Okay, so for now, let us compare the elements from both sides. Then, starting with the first column, we are having 4A plus 3B equals to 1. We are going to call this as equation number 1. And then we have 5A plus 2B equals to 0. And then we are going to call this as equation number 2. Okay, so next, let us make B as a subject from equation number 2. Then we are going to have B equals to negative 5A over 2. And then we are going to call this as equation number 3. Okay, so next, let us substitute the value of B in equation number 1. Then we are going to have 4A plus 3 in brackets negative 5A over 2 equals to 1. Simplifying this, we are going to have 4A plus negative 15A over 2 equals to 1. Okay, so let us now combine the terms in our left hand side. Our equation is going to be negative 7A over 2 equals to 1. Making A as a subject, we are going to have A equals to negative 2 over 7. Let us now substitute the value of A in equation number 3. Then we are going to have B equals to negative 5 over 2 times negative 2 over 7. Solving this, we are going to have B equals to 5 over 7. Okay, so next, let us consider the second column. So we are having 4C plus 3D equals to 0. We are going to call this as equation number 1. And then we are having 5C plus 2D equals to 1. And then we are going to call this as equation number 2. Okay, so let us make C as a subject from equation number 1. Then we are going to have C equals to negative 3D over 4. And we are going to call this as equation number 3. Okay, so now let us substitute C in equation number 2. Then our equation is going to be 5 times in brackets negative 3D over 4 plus 2D equals to 1. Solving this, we are going to have negative 15D over 4 plus 2D equals to 1. Solving further, we are going to have negative 7D over 4 equals to 1. Okay, so now let us make D as a subject. Then our equation is going to be D equals to negative 4 over 7. Now we have the values for D. Let us substitute this in our equation number 3. Our equation is going to be C equals to negative 3 over 4 times negative 4 over 7. Of which, solving this, we are going to have C equals to 3 over 7. Therefore, matrix A equals to negative 2 over 7, 5 over 7, 3 over 7, and negative 4 over 7. And this is going to be our answer. For part B, Amani and Asha bought Coca-Cola and Pepsi drink for farewell party. Amani spent shillings 9,950 to buy 12 bottles of Coca-Cola and 5 bottles of Pepsi drinks. Asha spent shillings 8,150 to buy 9 bottles of Coca-Cola and 5 bottles of Pepsi drinks. We are supposed to formulate a system of linear equations and hence apply the matrix method to find the price of one bottle of each type of a drink. Okay, so first let us start by assuming the variables. First, we are going to let X be the price of one bottle of Coca-Cola and Y be the price of one bottle of Pepsi. Okay, so now let us formulate the equations using the variables X and Y. Then the equation for the amount spent by Amani is going to be 12x plus 5y equals to 9,950. So we are going to call this as equation number 1. And also, the equation for the amount of money which Asha spent is going to be 9x plus 5y equals to 8,150. And then we are going to call this as equation number 2. Okay, so we've been told to use a matrix method to solve these equations. Then next, let us express these equations in a matrix form. Our equations are going to be matrix 12, 9, 5, 5 times matrix X, Y equals to matrix 9,950, 8,150. Let us call this as equation number 3. Okay, so next we are going to let A equals to matrix A, B, C, D, which equals to this matrix 12, 9, 5, 5. Okay, so next we are going to find the inverse of matrix A using the following relation, which says A inverse equals to 1 over AD minus BC times matrix D negative B negative C A, of which this matrix is obtained by exchanging the elements from the main diagonal and change the sign for the elements of the leading diagonal. And this is the adjoint of a matrix A. Okay, so now let us substitute the values which we have. Then A inverse is going to be 1 over 12 times 5 minus 9 times 5 times matrix 5 negative 9 negative 5 12. Solving this, we are going to have matrix A inverse equals to 1 over 15 times matrix 5 negative 9 negative 5 12. Okay, so next let us multiply A inverse both sides in equation number 3. Then our equation is going to be 1 over 15 times matrix 5 negative 9 negative 5 12 times matrix 12 9 5 5 times matrix X Y equals to 1 over 15 times matrix 5 negative 9 negative 5 12 times matrix 9,950 8,150. Okay, so we have to remember that a matrix times its inverse equals to an identity matrix. Then in this part, we are going to replace this with an identity matrix. Then our equation is going to be matrix 1, 0, 0, 1 times matrix X, Y equals to 1 over 15 times matrix 5, negative 9, negative 5, 12 times matrix 9,950, 8,150. Okay, now we have to remember that an identity matrix times any matrix, the result is going to be the matrix itself. Then for this part, we are going to replace with just the matrix X and Y. Then our equation is going to be matrix X, Y equals to 1 over 15 times matrix 5, negative 9, negative 5, 12 times matrix 9,950, 8,150. Okay, so now let us multiply the matrices from our right hand side. Our equation is going to be matrix X, Y equals to 1 over 15 times matrix 5 times 9,950 plus negative 5 times 8,150 negative 9 times 9,950 plus 12 times 8,150. Solving this, we are going to have X, Y equals to 1 over 15 times 9,000, 8,250. Okay, so next we are going to apply scalar multiplication for our right hand side. Then we are going to have X, Y equals to 1 over 15 times 9,000, 1 over 15 times 8,000 250, of which solving this we are going to have 600, 550. So next we are going to compare the elements from both sides. Then we are having x equals to 600 and y equals to 550. Therefore, the price of one bottle of Coca-Cola is 600 and the price of one bottle of Pepsi is 550. Part C of the question, point A with 4,2 is reflected in the line y plus x equals to 0, followed by an anticlockwise rotation through 90 degrees about the origin. We are supposed to find the final image of point A. Okay, so this is the transformation problem. We are going to start with the reflection in line y plus x equals to 0. So first, let us make y as a subject. We are going to have y equals to negative x. Okay, so for this one, we have also to remember that this line is going to make an angle with 135 degrees with the x-axis. We can as well see this from the figure below. Okay, so next we are going to use the relation for reflection, which says x image y image equals to matrix cos 2 theta sin 2 theta sin 2 theta negative cos 2 theta times matrix x y. From our question, we have been given the values for x and y from the point A to be 4 and 2, and then our theta is 135 degrees. Okay, so let us now substitute these values into our relation formula. Then our equation is going to be x image y image equals to matrix cos 2 times 135 degrees sin 2 times 135 degrees sin 2 times 135 degrees negative cos 2 times 135 degrees times matrix 4, 2. Okay, so next let us solve the values inside this matrix. So our equation is going to be x image y image equals to matrix cos 270 degrees sin 270 degrees sin 270 degrees negative cos 270 degrees times matrix 4, 2. Okay, so from here, recording the values for cos 270 degrees, which equals to 0, and sin 270 degrees, which equals to negative 1, then let us substitute these values into our equation. Then our equation is going to be x image y image equals to matrix 0, negative 1, negative 1, 0 times matrix 4, 2. Okay, so next we are going to apply multiplication of a matrix for our right hand side. Then our equation is going to be x image y image equals to 0 times 4 plus negative 1 times 2, negative 1 times 4 plus 0 times 2. After solving the values, we are going to have x image y image equals to matrix -2, -4. And this is an image for the reflection. Okay, so next, an image is rotated in an angle of 90 degrees. Okay, so let us consider the following relation for rotation, which says x image y image equals to matrix cos theta sin theta negative sin theta cos theta times matrix x y. Okay, so now let us substitute theta with 90 degrees and x and y with -2 and -4. Then our equation is going to be x image y image equals to cos 90 degrees sin 90 degrees negative sin 90 degrees cos 90 degrees times matrix -2 -4. We have to recall that cos 90 degrees equals to 0 and sin 90 degrees equals to 1. Then let us substitute these values into our equation. Then we are going to have x image y image equals to matrix 0 1 -1 0 times matrix -2 -4. Okay, so let us calculate our right hand side. Then our equation is going to be x image y image equals to matrix 0 times -2 plus -1 times -4, 1 times -2 plus 0 times -4. After solving the values, our equation is going to be x image y image equals to 4 -2, and this is an image requested. Therefore, our final image is going to be 4, -2. Question number 14, part A. Suppose a function f is defined by function of x equals to, in brackets, x plus 2 squared. We are supposed to find the domain and range of the inverse of the function f. Okay, so this is the function problem. We have been given the function of x equals to, in brackets, x plus 2 squared. Okay, so finding the inverse of this function, first we are going to let function of x equals to y. Then our equation is going to be y equals to, in brackets, x plus 2 squared. Okay, so now let us interchange the variables. Then our equation is going to be x equals to, in brackets, y plus 2 squared. Okay, so next we are going to apply square root both sides in order to eliminate a square. And we have to remember to apply the plus or minus for the root. Then our expression is going to be plus or minus under root x equals to y plus 2. Okay, so next let us make y as a subject. Then our expression is going to be y equals to -2 plus or minus under root x. Okay, so now we are going to let y equals to inverse of a function x. Now the inverse of a function x is going to be -2 plus or minus under root x. And this is going to be our answer. Okay, so we know that domain are values of x that make y to be defined, and range are values of y that make x to be defined in a function. In our function y equals to -2 plus or minus under root x. So starting with the domain, for y to be defined, the values of x must be greater or equal to 0, because a negative number will give complex number for a root. So we are going to have under root x is greater or equal to 0. Let us now square both sides. Our equation is going to be x is greater or equal to 0. And this is the domain values. And for the range, we are going to use this equation which says x equals to, in brackets, y plus 2 squared as obtained above. Okay, so we see that any value of y will make x to be defined, meaning the range are all real numbers. Therefore, we can conclude that domain is such that x is greater or equal to 0, and range is such that y is any real number. Part B, a businessman plans to buy at most 210 sacks of Irish and sweet potatoes. Irish potatoes cost shillings 30,000 per sack, and sweet potatoes cost shillings 5,000 per sack. He can spend up to shillings 2.5 million for his business. The profit on a single sack of Irish potatoes is shillings 12,000, and for the sweet potatoes is shillings 10,000. How many sacks of each type of potatoes the businessman will buy in order to realize the maximum profit? Okay, so this is the linear programming problem. Then first we are going to choose the variables to represent each type of potatoes. So we are going to let x be number of sacks for Irish potatoes and y be number of sacks for sweet potatoes. So next, let us form the inequalities from the information given. We have been told that a man plans to buy at most 210 sacks, meaning the sum of the sacks for Irish and sweet potatoes must be less or equal to 210. Then our inequality is going to be x plus y is less or equal to 210. Also, we've been told that Irish potatoes cost 30,000 per sack, then the cost for x sack will be 30,000 x. And then sweet potatoes cost 5,000 per sack, then the cost for y sacks will be 5,000 y. But he can only spend 2.5 million, meaning the sum of 30,000 x and 5,000 y should be less or equal to 2.5 million. Then our inequality is going to be 30,000 x plus 5,000 y is less or equal to 2.5 million. Okay, so now let us finalize our list of inequalities by including the non-negative inequalities. So we are going to have x is greater or equal to 0 and y is greater or equal to 0, because the number of sacks cannot be negative number. So after having all the inequalities, let us now form the objective function. We have been told that 12,000 is a profit per Irish sack and 10,000 per sweet potato sack. The total profit for x and y number of sacks is going to be 12,000 x plus 10,000 y. Then our objective function is to find the possible values of x and y that will give a maximum value of a sum. Then our function is going to be function of x, y max equals to 12,000 x plus 10,000 y. Okay, so next we are going to draw the graph using the boundary lines from the inequalities we have. So from the inequalities, our boundary lines are going to be x plus y equals to 210, 30,000 x plus 5,000 y equals to 2.5 million. So now we are going to use the intercept method to find the sample points. Okay, so starting with this line, x plus y equals to 210, then we say when x equals to 0, y is going to be 210, and our point is going to be 0, 210. And when y equals to 0, x is going to be 210. Then our point is 210, 0. Our next line is 30,000 x plus 5,000 y equals to 2.5 million. Simplifying this, our equation is going to be 6x plus y equals to 500. Okay, so for this one, when x equals to 0, y is going to be 500, and our point is going to be 0, 500. And when y equals to 0, x is going to be 166, 2 over 3. And our point is 166, 2 over 3, 0. So when drawing the graph, we are going to start by drawing axes, and we are going to shade negative sides of axes for inequalities. X is greater or equal to 0, and y is greater or equal to 0. Then next, we are going to draw the line x plus y equals 210, and then we are going to shade according to the inequality. And then next, we are going to draw the line 6x plus y equals to 500, and we are going to shade according to its inequality. Our final graph is going to be like this. Okay, so now we are going to summarize the corner points from the feasible region, and we are going to substitute in our objective function. So we are going to prepare a table. Here we are going to have corner points, and here we are going to have our objective function, which says function of x, y max equals to 12,000 x plus 10,000 y. So our first point is point O with 0, 0. Then the value here is going to be 0. Then our next point is A with 0, 210. Then applying these values into our objective function, the value here is going to be 2.1 million. Then for point B with 166, 2 over 3, 0, the value here is going to be 2 million. And for the point E with 58, 152, applying these values into our objective function, the figure here is going to be 2,216,000. Okay, so from the table above, we can see that point A gives the maximum value for our objective function. Therefore, we can conclude that a man must buy 58 sacks of Irish potatoes and 152 sacks of sweet potatoes in order to realize the maximum profit.